Shrewd Manager Christianity's position. The Big Bang implies it's reasonable to ask if the Turin Shroud is a miracle. Someone or something made the Turin Shroud, either a causal agent, like an artist, or a causal event, like a chemical reaction. We've been considering the obvious causal agent, a craftsman, but many believe the causal agent was God. Over the next several videos, we consider whether this belief is reasonable. See these resources. Now most people believe the universe is finite. It began. The universe, including all matter and energy, space, and time, began as an infinitely small, hot, and dense point, which rapidly expanded into the still growing cosmos we observe today. Prior, most believed it was eternal. Scientists call this beginning the cosmic singularity. The rest of us prefer the catchier name, Big Bang. Briefly, here's the evidence. Einstein's special relativity theory poses a riddle. If you go back far enough in time, you exceed the speed of light. But this is impossible. How can a valid theory both require and prohibit exceeding light speed? A lesser man would have pulled out his hair at this puzzle. A finite universe provides a solution. You arrive at the start before you break the speed limit. Many discoveries agree. Slipher noted that light from distant nebulae appears redder than expected. Since bunched wavelengths of light appear bluer and stretched ones appear redder, he reckoned these clouds of dust and gas are moving away from us and calculated their velocities. Hubble tested Slipher's work. Using the most advanced telescope of the day, Hubble confirmed the so-called redshift and added key details. They're not nebulae, but many distant galaxies beyond the Milky Way. Lemaitre correlated Slipher's data with Hubble's distance measurements. Farther galaxies recede faster than nearer ones. That is, the universe appears to be expanding in all directions, like an inflating balloon or exploding grenade. This implies a detonation point, a singularity whence the universe began. Combining all this, Hubble computed the age of the universe. In the 1940s, Alpher and Herman, working with Gamow, predicted a detectable afterglow for this explosive creation event. Later, Penzias and Wilson found this afterglow, known as cosmic microwave background, or CMB. CMB has been observed by many researchers and with many spacecraft missions. Most famously by NASA's Cosmic Background Explorer satellite, the COBE, which mapped the sky in the 1990s. Gamow calculated that only a universe expanding from a near infinitely hot beginning accounts for the abundance of elements we see. Hoyle, the singularity skeptic, showed that the relative abundance of helium is consistent with the universe being created from nothing. Einstein's concept of gravity expressed in his general relativity theory also points to an expanding universe. It holds that massive bodies curve space, but this predicts space would contract in on itself and we'd live in a giant black hole. We don't. We live in a universe with empty space between massive bodies. Einstein posited a cosmological constant, an outward pushing force to counter gravitational attraction. This push-pull implies a dynamic, expanding, and finite universe. Like CMB, general relativity has been confirmed in all contexts. By 1919, it passed its first big test, when Eddington proved the sun's gravity bends starlight by the amount general relativity predicted. And by 1980, a hydrogen maser clock aboard a NASA rocket confirmed general relativity to the 5th place of the decimal. Hawking and Penrose proved the singularity includes not only matter and energy as Einstein proposed, but that space and time also began at the Big Bang. In the 1990s, Bohr, Guth, and Vilenkin demonstrated that any universe that is on average expanding must have a beginning. As Vilenkin, an agnostic, put it in 2006, cosmologists can no longer hide behind the possibility of a past eternal universe. There is no escape. They have to face the problem of a cosmic beginning. If stars are distant enough, light emitted at visible wavelengths would reach us in infrared. The James Webb, an infrared space telescope, confirms the expansion even from these earliest galaxies. That's a lot of evidence for the singularity. Let's talk implications. Is anything more fundamental to our scientific and common sense understanding of the natural world than the law of cause and effect? Space and time, matter and energy all began. These are the effects. Intuitively, we know the cause must therefore be non-spatial, eternal, immaterial, and very, very powerful. If matter didn't exist until caused, the cause must be immaterial. If space didn't exist until caused, the cause must be non-spatial. Likewise with time and energy. That's a pretty good start to a definition of a godlike creator. Not everyone agrees. Many alternatives to skirt these implications have come and gone. New ones arise regularly. Examples include the quantum creation equation, steady state, oscillating, eternal inflation, pulsating, and self-stretching universes. Are these strong enough to overturn what we intuit as true and reasonable? We don't think so. Here's why. First, another equally intuitive reason is easy to illustrate. If a wind-up toy car is running across the floor, you know something wound it. That's cause and effect. But you also know it was wound a finite time ago, otherwise it wouldn't be running. Per the first two laws of thermodynamics, a self-contained universe is no different. The total quantity of energy is constant, but the usable energy decreases. Since the universe still has usable energy, it is finite. Second, opposition to causal implications of a beginning tends to be philosophical, not scientific. To avoid the conclusion of a changing finite universe, Einstein altered his own equations, arbitrarily assigning a precise value, so the cosmological constant exactly offsets the strength of gravity. However, to his credit, after investigating Lemaitre's and Hubble's work, he retracted this arbitrary value, announcing that denying evidence for a beginning was the greatest blunder of his scientific career. Eddington called the notion of a beginning repugnant, and the expanding universe preposterous, leaving him cold and wanting to find a loophole. Where's the science in that? In 1989, John Maddox, editor of the preeminent science journal Nature, penned Down with the Big Bang, calling the theory philosophically thoroughly unacceptable because it implies an origin of our world whose cause or causer lies beyond the universe. The Big Bang theory, he predicted, is unlikely to survive the decade ahead. We'll call this failed prediction Maddox's wishful thinking. According to Cambridge-educated Dr. Stephen Meyer, unlike opponents' popular writings, their actual technical papers reaffirm and presuppose the singularity. Often they rebrand the same inferences with terms they find more palatable. The cosmological constant is akin to unexplained fine-tuning. Penrose's phantom field is a creation event by another name. Quantum creation equation, or QCE, is intelligent design, with the scientists themselves usurping God's role. Here's why. QCE mathematically combines quantum mechanics and general relativity, but it can only explain a universe like ours if researchers program constraints into the formula. Opponents say a finite universe doesn't need a creator. It can spring from nothing. However, their nothing always seems to be something, redefined as nothing. For example, Hawking writes, because there is a law such as gravity, the universe can and will create itself from nothing. Oxford mathematician John Lennox calls this self-contradictory nonsense. The law of gravity is something, not nothing, and it depends on nature, it doesn't create it. Third, proposed alternate mechanisms won't get the job done. They are causally inadequate. Meyer's book, Return of the God Hypothesis, expounds a method called inference to the best explanation. Every worldview or metaphysical system has to answer the prime reality question. What is the thing, entity, or process from which everything came? Meyer proposes different candidates and compares their causal adequacy. Quantum creation requires a set of mathematical equations, but in our experience, math always exists in a mind. If QCE is true, if math predates the universe, there must be a mind in which to hold that math. Further, in 2015, Vilenkin wrote, "The theory of quantum creation is no more than a speculative hypothesis. It is unclear how or whether it can be tested observationally. Materialism and naturalism are likewise incapable of explaining such a reality. Before the material universe existed, there was no matter to do the causing." Pantheism, such as found in Eastern religions, equates God and matter, meaning neither God nor matter were available to do the causing. Theism and deism's answer to the prime reality question is an eternal, self-existent, transcendent creator, one that exists outside the universe of space, time, matter, and energy. Meyer concludes this is the best candidate to explain observational astronomy and the singularity and BGV theorems. Fourth, the Big Bang is a new illustration of a 4th century metaphysical argument, popularized by scholar William Lane Craig as the Kalam cosmological argument. It says whatever begins to exist has a cause. The universe began to exist. Therefore, the universe has a cause. Meyer's case complements this ancient one with his conclusion that a theistic creator provides the best causal explanation. Let's sum up our view of mainstream scientists' bias. Eternal universe? No problem. An eternal God? Huge problem. Something from nothing without a creator is fine, as long as the nothing is really something. Next, what does the Bible say?